Hello, and welcome to today's lesson on parallel and perpendicular lines. Our essential learning goals: by the end of the lesson, determine if two lines are written in slope-intercept form, are parallel, perpendicular, or neither. Rewrite equations of lines from point-slope form into slope-intercept form and determine if they are parallel, perpendicular, or neither. So before we start looking at the equations, we need to review the two definitions. Okay, what does it mean for two lines to be parallel? When we're looking at parallel lines, okay, they're coplanar, so they lie in the same plane or they would be on the same surface, tabletop, desk, smartboard. Okay, they have the same slope, same direction, positive, negative, same rate of change. Okay, but they have to have the different y-intercepts to make sure that they're in separate spots, separate positions within that same plane. So when you look at the football field here, we've got all of our yard lines are parallel lines. Okay, they lie in the same plane. Okay, they have the same slope, they're going in the same direction, okay, but they never cross each other as we go. Okay, now, what does it mean for two lines to be perpendicular? Okay, they need to intersect at a 90-degree angle. Okay, so when we look at perpendicular lines, we're going to talk about, it's kind of small over here, we can see that opposite reciprocal or negative reciprocal slope. Okay, so first, looking at slope-intercept form of a line equation. Okay, we've got our slope value, okay, that we found in one of our last lessons, and then the y-intercept. Where does the graph cross the y-axis? So remember, the y-intercept always happens when the x value is 0. So it's 0, comma, some number, 0, comma, b for that y-intercept value. Okay, so that's our slope-intercept form. We'll also be looking at what we call point-slope form, because sometimes we need to start with point-slope form before we can get into slope-intercept form. So looking at these equations here, okay, two lines are parallel, okay, which means that they are coplanar, lying in the same plane, have the same slope, and different y-intercepts. So when we look at the line equations, we're identifying the pieces. Okay, we have a slope of -2. Okay, this one has a slope of -2. Now, we can't say that they're parallel yet until we look at the y-intercept. Okay, and we always want to think about the y-intercept. We can think about it as an equation, okay, but we also want to think about it as the coordinate value. Our y-intercept here is 7, 0, or we can say that y equals 7 for the y-intercept. Okay, same thing here. We have a 0, -19, y equals -19 for the y-intercept. So since the y-intercepts are different, the slopes are equal, then yes, we can say that we have parallel lines. Okay, perpendicular lines intersect at a right angle, and if we think about this in terms of the coordinate axes, okay, some of this stuff starts to make a little more sense if we're looking at a couple of lines. Okay, so if we have our line here, okay, positive slope, any perpendicular slope to it, you can see is going in the opposite direction. Okay, so that's where the opposite part of the opposite reciprocal comes from. And then reciprocal just means the rate of change has been affected in the other direction. So the opposite reciprocal of 2/3, okay, we need the opposite sign. So it started out as a positive, we need to make a negative, and then the reciprocal is basically saying flip the fraction. In our second slope that we have here, we have a negative 9/4. So we need a positive for the opposite and a 4/9 for the reciprocal. Remember, always try to go back to this mental picture and understand that when we're finding a perpendicular slope, we're changing the direction of the line, and then we also have to change the rate of change of the values. Okay, now, for our last one here, we've got a -7. What we want to remember, turn it into a fraction over 1, and then we can convert to our opposite reciprocal slope, positive 1/7. Now, when you have positive slopes, you don't have to put the plus in front. I'm just doing that here for emphasis. Okay, now, looking at these two lines, are these two lines perpendicular? Okay, so we're looking, it looks like they're perpendicular. We can see the opposite slopes, but we really have to go through and do the work to see if it is. So let's find the slope of our first line. Since we have a graph, slope is always easiest to be done with a counting principle. Okay, our slope of the first line, we are going down 3 to go right 5. So if we're going down 3, our y's are negative change in y. Okay, we are going right 4 spots to go from 1 to 5. So we have a -3/4 slope. The negative makes sense because it's pointing to the negative side of the x-axis. Okay, it's also pointing to that empty side if you think about the fuel gauge in a car. And then we have our second line here. Okay, our second line, we're always looking perfect point to perfect point when we're going and working with some graph values. We've got a 3-unit change horizontally, a 4-unit change vertically. Okay, so remember, when we're thinking about slope, change in y from one point to the next, okay, it is a +4 change in the y coordinates. It's a +3 change in the x coordinates. So when we look at the two slopes, are they perpendicular? Yes. We have the opposite sign, we have the reciprocal slope, or the reciprocal fraction for those values. Okay, so that does make it work properly for what we're looking for to have a perpendicular slope. Okay, now, just some quick practice. How can we find parallels? How can we find perpendiculars? Okay, looking at any type of slope that we can be given. Okay, slope of A over B, the parallel is A over B. The perpendicular, opposite sign, negative, and we flip the fraction to get a negative B over A. If we're looking at a slope of a -2, parallel is -2, perpendicular, positive, changing the sign, flipping the fraction to a 1/2. If our original slope is 2/3, okay, parallel is 2/3, perpendicular, -3/2. Now we have to be careful of this last situation. Our slope is 0, parallel is 0. What's the perpendicular? Undefined. Okay, we have to remember that vertical line has no slope, it has an undefined slope. Okay, so there's a difference between no slope and a 0 slope. We really want to use the term undefined for a line that does not have a calculatable slope. Okay, now, looking at this scenario, we're missing one point from this picture. Okay, we want to put in a point D that is parallel to BC. Okay, so think about what we would do. Parallel means that this point has a similar slope but a different y-intercept. So the first thing we want to do is we want to find out what's happening with the slope from BC. So to go from 5 to -3, we're going down 8. Okay, so we're finding the slope of BC. Okay, our change in y is a -8. Our change in x, we're going in the positive direction, 1, 2, 3, 4, 5. Okay, so that's the slope of that one. -8 change in y, +5 change in x. Okay, so when we're looking to place the point D, there's two ways we can do it. We can place that point, we could find it algebraically if we want, and I'll show that as well. But anytime you have graph paper, okay, and you can make a very simple graph paper, you can print graph paper off of Google, just find some graph paper to work off of. What we can do is we can follow that same slope to place that second point. 1, 2, 3, 4, 5, 6, 7, 8. So we've gone down 8. We're matching the change in y over 1, 2, 3, 4, 5. Okay, we've got that change in x of a +5. Okay, matching what we've had for the second one. And now we have the point that we're looking for. So we know that D has to be the point to -6. Okay, now, how could we find this algebraically? We know the slope of BC. We know if we're parallel, we have to match that slope. And we have our A point, which is -3, 2. So if I want to find the slope of AD, that's going to be equal to, and in this case, I would always put the variable first. Y -2 over x minus a -3 or +3 is going to equal the slope that we're looking for. Okay, notice by putting the variable first in these equations, it's going to stay positive. Otherwise, you'd be working with negative signs, and that always makes things a little bit more difficult. Now, we have our -8/5 is what we're replacing this slope with because we need to be parallel to that line, equals y -2, x +3, and now we come back to the number one concept in all of mathematics: cross multiply and solve. Be really careful when you're working with equations that you put them in parentheses when you cross multiply. And now we can distribute and solve. Okay, so we've got -8x plus 24. Actually, it's a -24. Equals 5y -2. I made a mistake there. That should be a 10. Okay, now what we're doing here in this situation, okay, we have it set up well. We're looking for what we need. Okay, there's a small issue here. Okay, hopefully some of you might have saw this already. We're looking at this scenario, and I've got two variables when I'm trying to solve. Okay, and I wanted to show this situation because sometimes we try to work through things algebraically, okay, and we can't get to a proper solution based on the fact that we have the two variable situation. So how can we deal with this overall? I hope some of you are looking and seeing, because this is what we want to get to, the fact that we actually just have two separate equations. The -8 equals y -2. So then we can solve for our y value. We add 2 to both sides. We get our y value of -6. And then we've got our x value situation where x +3 equals 5. We subtract 3 from both sides, and we get x = 2 to finish out the coordinate point. okay, that we were already able to find graphically. So that's a big thing here, is remember, if you can have graph paper to work off of, it is a major advantage to you anytime we're dealing with geometry. Okay, so now let's finish up our last problem here. Quadrilateral hand, H-A-N-D. We've got the 4 points. We want to know, is this a parallelogram, rectangle, or neither? So what we want, just like I said, we want to go in, we want to find some graph paper here. Okay, so I'm going to pull up some graph paper. Because whenever possible, we want to be able to graph the points, we want to see what's going on, making a picture for ourselves in this situation. So we've got our first point, -5, -1. That's our point H. We've got A, which is 7, 1. We've got N, which is 6, 7. And we've got D, okay, we have point D, which is -6, 5. Okay, and what we need to know, we need to find the slope of all 4 lines. Okay, so you can use the slope formula to do it. Okay, this is why I prefer the picture. Okay, the picture helps us find a slope a little bit quicker because we can go through and count from point to point. Here, from left to right, and that's how we always want to work from any one point to the other, we're going up 1 and over 1, 2, 3, 4, 5. Oop, messed up on that one. We need to go up 2 in this situation, okay, to get on the correct level of the other point. And then over 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Okay, so our slope up 2 over 12, okay, we could reduce that to a slope of up 1 over 6. Okay, now let's see if we have a matching slope down below for a parallel. Up 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we do have the matching slope of 212 or 1/6 for top and bottom. So that tells us that we're well on our way for a parallelogram. We just have to check the other 2 side slopes, and we'll do that next. So from point to point, we're going from left to right. I go down, because we always want our change in y first. Down 1, 2, 3, 4, 5, 6, and we're going over 1. Okay, so we have a slope of down 6 over 1. Let's check the other side. 1, 2, 3, 4, 5, 6 over 1. So we're going down 6 over 1 as well for a -6 over 1 slope. So now we know for sure it's a parallelogram. We have equal slopes on parallel sides. Okay, so we have 2 sets of parallel slopes. Now we need to know, is it a rectangle? What makes something a rectangle? A perpendicular angle in the corner of the parallelogram. So let's look at our 2 slopes. We've got a 1/6, and we're comparing that to a -6 over 1. Are these 2 opposite reciprocal slopes? Yes, they are. So we know that we have a 90-degree or perpendicular angle, and that does make it a rectangle. Okay, so that concludes our lesson for today. Have a good day with the homework, and we'll talk to you soon.